Welcome to the Meltzone podcast. This is episode 48, recorded on July 4th, 2021. I'm Tom.
And I'm Stefan. And today's episode has quite a lot of recycling topics. So we start with material, filament, and 3D printing recycling. Then we continue with recycling filament spools. Is cardboard better than plastic? Then we continue with a really interesting process of recycling PET bottles with the PETBot. And we end with, the recycling of fiber reinforced wind turbine plates chopped down and put into PLA plastic.
Also, one of the things that was happening last weekend is MRRF. The Midwest Rep Festival has been put on under adverse conditions, and one of the products that launched there is the Lulzbot Sidekick in the 289 and 747 variants. We talk about how that fits in and what's been happening with that launch, and about another launch, which was Chitubox Pro, the software that pretty much every low-end resin printer uses these days, and how that is now a base version and a paid subscription for a pro version, and what that might mean for the future of the low-end resin market. Also, we answer questions all throughout this episode. We don't have a real Q&A segment today, but one of the questions we answer at the end is what would be a good filament, a good printer for making reproducible parts at home for yourself. I guess that's not really part of the question, but we answer it anyways.
It's getting hot in here.
Perfect temperatures to run a filament recycling system, isn't it?
Well, it's perfect weather to run a filament recycling system because that's down in my basement where it's way colder. Where I enjoyed, just being the last couple of days and even weeks more and more. Because, don't have any AC in here. Thought about
Still
it.
Not.
Still not. I'll be buying a fan. And if I properly vent my office early in the morning, it's not that bad. But I think it's, again, really toasty in here again. It's 27 degrees, which is a lot of Fahrenheit.
Yeah, few. I still have my my electric radiator going here, my heat lamp essentially, because I am actually in the basement down here recording, and it is kind of cold. My feet are getting cold, so it's interesting. It's interesting. So I'm sweating up here, and I'm hoping for an air condition. You are down in the basement having your heater running. So what I noticed, so I have the inverter of my solar system and also my whole network switch and everything, which is connected to that down in basically my workshop. And usually it has been around 17 degrees, like all year round. But now, since we get quite a lot of solar energy down there, it has been gradually warming up, and I think we are already at 22 degrees Celsius. It's basically a perfect temperature for full working. Unfortunately with my inverters, they do make some noise. They do have they have fan noise, and they also make like invertery noises. Okay. So they have a very nasty high pitched whine to them. So the room that they're in really is just storage. You can't really do anything in there, but it is getting really toasty. It's 22 kilowatts of solar inverter power, and it's also 22 kilowatts of solar coming down from the roof at times. And at, I don't know, what are they, 97-ish% efficient? That sounds really good, but 3% of 22 kilowatt is still a lot of heat to put into a room. That's getting toasty as well, but it's literally at the opposite end of this basement.
Okay.
How have you been holding up? So we're skipping right past the filament recycling topic. How have you been holding up in the recent storms? Any flooding with you?
No flooding on my side. So if we would get flooding, that would only be if we get a lot of rain over a longer period of time, since we're living next to a river, and that's usually doesn't really significantly raise its level when there's just a thunderstorm. So we were kind of hit. A couple of tomatoes died. But not that much worse. Just like a kilometer to the west, where I'm living, they really got like tish tennis, ping pong ball sized hail, and they seriously got some damage there. So cars didn't look that well afterwards.
I bet.
There was a tree in front of the house of a friend of mine where the security camera captured where it got blown over and like crashed on the neighbor's car.
But that's all insured, right? Well, which insurance pays for that? Is that the car's Vollkaskoversicherung, or is it the homeowner?
It's the Teilkasko.
Okay,
that should.
Right.
I don't know. Well, I think that was a tree which belongs to the city, but I don't know if you're getting smashed by a tree. I think at first the Teilkasko is paying, and then maybe the Teilkasko tries to get the money back from the tree owner.
But at that point, it's not your problem anymore.
Yeah.
But like, what's the tree owner going to do? Like, tie down that tree?
No. Yeah. How have you been? I heard that at least in the past you already had a bit of water in your basement.
Yeah, so we are living sort of next to the Isar, the same river that flows through Munich, and we're basically in the Isar glacier bed, former glacier bed. So it's all flat, and we're basically at the same level as the river, though the river is like almost a kilometer out. But the house is basically sitting in groundwater. So it's like the regularly groundwater is like a meter down from the basement floor. But when it rains, that rises up really considerably. And what always happens is it pushes through the walls. So where there are windows, there used to be a window here that I've boarded up. But wherever there are windows in the basement here, the concrete crack, the typical 45-degree crack angle, because you have those stress concentrations in the corners, and that has been filled with polyurethane at some point, but stuff keeps settling, stuff keeps moving, and that's where water pushes in. Also from the sewer system, because here the gutters are still connected to the sewer system, so all that water from the gutters presses into the sewer system, and it has nowhere to go because everybody else is also pressing in, so it tries to back up, or it tries to back out of where we, for example, have washers connected and stuff. So that's we always get a bit of water pushing into the basement. So far, it's been holding up pretty well. That stuff hasn't really been underwater. We've had that in the past where we had like knee-deep water in here, which isn't pretty at all. But I don't know. I'm kind of worried because events like these they're not getting any rarer, at least. So I don't know. The entire studio's in here, and if this stuff gets flooded. Yeah, I'm a couple 10,000 euros deep in equipment that's ruined. Also, everything else that's in the other basements. So I don't know.
Plus the additional work that you would need to put in to get everything like clean again and dry again.
Yeah, but that's just for the stuff that's in here, plus damage to the house. So I don't know.
Since you got this like groundwater moisture problem, do you constantly run a dehumidifier where you okay?
Yeah, so one's over in the workshop because otherwise my tools would just rust away, and you can see that with regular steel tools that are not chrome plated or anything, they just start to rust. And also in the studio because I have the ERV, the energy recovery ventilation system. That does introduce a bit of moisture, even though it's supposed to like equalize it a bit, but that still introduces here. I've been running a dehumidifier in here as well. It's off right now because it makes noise, but typically that runs controlled by the solar system, which is nice. Yeah. So it only runs when there is excess solar power.
Because otherwise all of the filaments behind you would probably get really bad quickly. Yeah, well, PTG isn't that happy, but it works. Like, you can leave it out in the open. PLA as well. If it's like 80% humid in here, you could throw it all away without drying it. So, oh well, weathers. You've seen the ocean that's burning, right? Yeah, that looks really I don't actually want to say nice, but it looks really impressive.
It looks like a render challenge that like Corridor Digital put on or something. It's spooky. Canada's on fire. Madagascar is starving. And you're recycling filament, so you're doing something good.
I'm doing something good. Yeah. So as we started off, I continued my filament recycling efforts series. I don't know how I want to call it, but just getting back at it and also presenting to all of the other people out there what the challenges are, and maybe even but also discuss if something like that would be viable. Starting from what problems I already have only using my material that I thought was nicely sorted and controlled, but what challenges you would actually have when you would say, okay, let's start a filament recycling or a 3D printing recycling service. Send in your material and we will make new filament out of it.
That's been tried in the past, right? There have been companies that tried something like that. Maybe
something like that, but I haven't found anything that is still working, or that who are still doing that. Most, or maybe basically all of the recycled filament that you can currently buy is industrial waste, where you definitely know which grade of material that was, or which polymer in the first place it was, and which grade of polymer it was. You know that it's clean. You can easily sort it by color and things like that. But as soon as you
just the fact that you just have one type of polymer, that it's not like you have PLA and you've got a chunk of ABS, and that's really going to degrade your material quality. Okay,
so I have shown on Twitter that I have been collecting 3D benches over the last, I think, 2 years, starting from when I did my Fillerstruder series. And I thought, okay, it will be a nice project to extrude new material out of 100 3D benches, because one 3D bench is around 10 grams, so 100 3D benches is roughly just one roll of material.
Spool,
But over the last years, or when I started sorting or just pouring out the 3D benches, I already noticed, okay, there are some parts in there where I definitely know they shouldn't be recycled. So I had carbon fiber parts in there. I had copper plated parts in there. I had glow in the dark 3D benches in there. So I was already questioning myself, how can I be sure that all of the rest of the parts I have in there are at least PLA? How can I distinguish between PLA and PTG, which is the obvious contestant, because they have rather similar weight properties, stiffness properties, optical properties. ABS is kind of easy to distinguish just due to the fact that it's way lighter due to a lower density.
Yeah, and also with ABS, you rub it with a knife and you can smell that ABS smell if you want to, if you want yourself to distinguish it, and not just if you don't have the option to throw it all in a pot of water and see which ones float, essentially.
Yeah. Even though 3D benches don't float really nicely, but that's something else. So what I actually ended up doing, because I don't have expensive IR equipment that is used in commercial recycling plants to distinguish between different plastics, I put all of my 3D benches in the oven at 65 degrees Celsius, and I squeezed all of them, and the ones that were soft, I knew, okay, they are probably PLA. Yeah. But this was more or less the best thing I could come up with. Of course, you could do solvent tests or smelling tests, or I don't know, weighing tests, but weighing or checking the density is also hard if you have a part with infill. Yeah. And then, for example, with PLA and PTG, the density is pretty similar. It is challenging already with my small setup. Now just think about how it would be if you have 100 customers sending in their Yeah, I think it's PLA, printing residues and support structure and stuff like that into your company. How could you make sure that everything is just that one type of polymer?
You can't.
And I think that is one of the most essential basic questions or problems that such a recycling system would have. I'm quite sure that there might be solutions for that problem, but I don't have them at the moment. And I think it is kind of nice to just put those questions out and see if we can get a discussion going, because there is really a lot of interest in recycling failed prints, but there are challenges that people need to think about, and it is not that easy. And also for small makers, it is not really feasible to recycle your materials, because already the amount of work I had to put in to sort the stuff,
even though it's stuff you had printed, you knew you could have known what he put in there, right?
Yeah.
So okay.
Yeah.
Let's actually
that's going to be part of the series, and
right.
I'm quite interested to see what people are going to say.
Yeah. We do have quite a few topics today, if you ever get to those, about recycling and reusing the filaments and the materials we already have. And I think I just pulled up or pulled to slot number 1 a question that we actually got. Usually we do questions in the end. But Astrosmoke's asking, hey, why are filament spools plastic and not recyclable? Well, they are recyclable, but they aren't recycled per se. So, typical filament spool. This is polystyrene. This is the typical German Hafner spool. And these have a little material marker on them. That is probably going to be super hard to see on camera there. This one's marked to polystyrene, and that's something that's actually super useful for sorting them later on. If it's not like immediately clear what material it is, you can look at the part and you see, oh, it's polystyrene. Or some commercial parts also have that recycling symbol on it that tells you what type of material it is.
It's especially important for those black parts, because they can't be automatically sorted with the IR equipment.
Yeah, because black is charcoal black or soot black, and that just absorbs everything. Yeah. So why aren't we making spools out of those sorted, recycled 3D prints basically that people send in? That could be an option, right? Because you don't care about the printability of a material. Printability is even more finicky, more sensitive than injection molding something, I would assume. And you don't care about material properties either, because these things are way too strong for what they need to do anyways. Could that be something to do with that?
Well, that definitely might be an option, because I think that the just processability for injection molding is easier. It's not totally easy in the end, but it's easier than if you want to extrude filament at a certain diameter with a certain quality and things like that.
Then need it to be printable in a FDM 3D printer, which by itself is already a huge mess to deal with all the parameters.
I guess the big problem in the end is that it's way more expensive than buying horribly cheap polystyrene pellets and having a process where you know that it just works. Because if you would grind up 3D prints and use them for injection molding, this will definitely be more hassle than using virgin material. And who is paying for that in the end? Because if somebody sends their 3D printing waste to a company, they expect to get something in return. But if the company that is doing that recycling and recycled spools is just paying more for the spool in the end, does that make sense?
Yeah, I mean, especially with shipping involved, that's I don't think in the end ecologically even that makes sense. But yeah, from the price perspective, this has, you can see the mold has indicators for polystyrene, ABS or SAN. What is that? Styrene something.
No, I think it's not styrene based. That's the material where lots of coffee machines or the transparent things of coffee machines are made of. No, sorry, it's styrene acrylonitrile resin.
Okay, so it's similar to ABS, as they all are. Polystyrene, ABS, and all styrene based. Polystyrene is incredibly cheap. So you can look up like bulk pellet or resin, as it's called, prices of just an octobin full of polystyrene, and you pay like $2 or $3 per kilogram, especially for polystyrene, which is super cheap. So a spool like this, you pay for your mold once, and you use once that mold is paid off, like you pay what, 50 cents for a spool like this in like production costs, and it's a machine that just works and works and works, and there's no labor involved. And like I said, Astro Smoke is also asking like, hey, why aren't we using cardboard spools? Which, to be fair, a couple of companies are using. Protopasta comes to mind with their corrugated cardboard spools. Who else? A couple other companies are also using like solid cardboard spools. But honestly, I've seen, I think it's in a video even, I've seen the way that Protopasta assemble those spools. They've got a hot glue setup basically right at the extruders, where they take the two halves and the center core and they glue it together. Just that labor, I think, is already more expensive than just buying a spool. So yes, it would be better to use a cardboard spool, for sure. It would be better to use a recycled spool, but in the end, it's capitalism. You do whatever is the cheapest for you, and that's what sticks. Also, people don't want to pay more for stuff most of the time.
Yeah, and I would need to compare the size, but I have the feeling that the usual 1 kilogram cardboard spools, they are bigger in the end. So I think the inner diameter is a bit bigger, or they are wider. Which also maybe adds up in storage or shipping.
Depends which.
Depends probably on the material.
I think the Protopasta spools even have a smaller core. So I'm looking at one right now. It's approximately same size.
There are more and more companies starting like using cardboard spools. There is Polymaker now with their Polyterra filament. Also, many other German vendors, 3D Jag material you get on cardboard spools, and a couple of other ones as well. Prusa, they have only the injection molded outer parts and the internal cardboard core, which is, at least for I wouldn't say recycling, but for disposing those, quite interesting, because they don't take up as much space, and they save on plastic as well.
Like the amount of plastic saved, it's like a 2 centimeter sliver in the center at best. Like it's the two halves still reach in pretty far over that center cardboard element. So though the hex pattern, I don't know if how much that actually saves, but I think that's also a consideration that they took into account, that might save some material. Yeah,
but in the end, usually companies that do filament extrusion, they don't also want to do injection molding for spools, because that's just an additional process where they might not have the machines for, or the equipment for, or whatever. It's just cheaper buying them in bulk. There are a couple of companies, and I know, for example, 3DK Berlin, which is a also German Berlin-based filament manufacturer. They, at least in the past, they used recycled PLA for their spools.
Okay, so that's pretty cool.
I think the PLA was maybe taken from just extruding filaments, so the transition parts, the stuff that is in the extruder after you stop the machine. And I also talked to them a while ago, and I think there was one yogurt manufacturer or something like that close by, where they had the possibility to get, I think, leftovers for the yogurt cups that they used, but again, not really for making the filament, but just for the spools.
The thing is, if you use like industrial refuse or industrial leftovers, those materials are so pure they would otherwise just go right back into material production. Like I think for polyesters in particular, there's always a significant amount of recycled materials in there because polyesters are just so great for recycling. That, you know, if you use those basically perfect leftovers for spools and for other like simple things and saying, oh, we've recycled them, it's just at another process, you need more virgin material again. So it's not, in the end, it doesn't really make that much of a difference. Yeah. So yeah, I think the problem is just plastic is too cheap. For it to be viable to do anything else, to do recycling. I mean, even with our German recycling system for like packaging plastics, most of the stuff is just getting burned. It's just used for fuel essentially. It's like you've got an oil power plant essentially, because it's not economically viable to recycle it. So yeah. What I also put in there is like why not use a master spool? Where you have master spool, I think that was like 2-3 years ago where that came up. I've got one on the shelf over there, but I can't reach it. Basically, you don't buy filament on a spool, you buy filament as a compressed ring, and then you put that onto a 3D printed or injection molded spool, and you reuse the spool. So you put that on there, you use up the filament, and then once you're done, you take the spool apart, you put a new ring of filament in, and that's good again. I think with the correct expectations, that could be a system that works. And I'm seeing I'm seeing a couple of companies actually adopt it. Dust Filament has always been great about offering their stuff in master spool format as well. What Chinese company did I see offering master spool?
Yes.
Compatible ones too.
I think Sunlu, or there were at least. I also received a couple of emails about we adopted the master spool. So I really like to use the master spool for my most common materials where I use for my most common colors where I know I use spool after spool after spool. But if I have like filaments that I rarely use, it would in the end be almost be a waste of plastic because the master spool weighs more than an injection molded spool that would be then kept on my shelf for ages.
Well, I mean, the idea is you can take filament off of a master spool. Like you can put the zip ties back in and you can compress it up.
But then you have the zip ties again. Or you could use like reusable zip ties, but in the end...
But what I'm trying to get is you can't take it off the spool. It's supposedly you can, but it doesn't work. Like you never get it as tight again, and it just keeps flopping around. And in the end, you take it off twice, and the spool's just completely mangled in garbage. So you really need to for stuff like you're saying, like black ABS or black PLA or something. Perfect solution, and I wish it was more widely available. But for now, because it's cheap, we just have plastic spools.
I think there are some companies that take the spools back and you get like a 10 or 20 cent discount as like, I think it's more or less a promo in the end, but you would need to send in a bunch of rolls to even make up the amount of money that it costs to ship them. So I don't know. I also feel kind of bad always when I throw those spools away because they don't. I think I would need to talk to somebody who knows it, but I think they are not supposed to go, for example, in the German Gelbe Sack system.
Okay, I always
because they are no packing waste.
Yeah, but that's not because they can't be recycled there. That's because the manufacturer of those spools didn't pay for that recycling system to be used because it's technically not a packaging material. Whatever.
Yeah.
Oh well. So that's recycling of spools and stuff. We've got one more recycling topic, but first, Stefan, why are you wearing a different shirt? Why am I wearing a different shirt?
I actually hope that I'm wearing a different shirt. Yeah, it's kind of strange. We might look a little bit different.
Yeah. Usually we don't edit these podcasts much. Like that was the entire intent of not doing of doing something that's more casual and doing something that's a bit less work for us, where you can just hang out and chat. But sometimes you have to edit if you record the wrong sponsor for a video or for a podcast. So this video sponsor, or I keep saying video, this podcast, this episode sponsor is actually JLC PCB. They're actually sponsoring next week's video on my channel as well. And they allow you to order PCBs that you design yourself, and you submit them. They make the PCB itself, and they also, this is actually the new one, they actually also populate them with the components you want. And that's something that I find incredibly fascinating, because a couple of years ago, that was just not something you could do. You could order PCBs, sure, from a lot of companies. I'm not going to name any competitors here, but you could order PCBs for a while. But if you wanted something that had a couple SMTs on there, that was impossible. You had to do through-hole. You had to like hot plate them yourself, which is a huge pain. And now we can just go in, design something in Eagle, and get them assembled. So Stefan, you've not done much in the terms of ordering electronics and stuff, right?
No, it's still on my bucket list.
Now's the time, really. It's literally never been easier than this. So I design my stuff in Eagle. You can use KiCad, which is free and does pretty much all the same stuff. And it's just so nice for a project but this is for the DC Powerwall, 384 cells connected to a PC and powering that while the solar is off and being charged from the PC while the solar is going. I literally couldn't do the project without having PCBs. So what this is basically a carrier for an ESP32. It's got a couple of DC-DC converters. It's got a plug-in ADC, because I want to be able to swap between different PCBs. That's the first revision, second revision. I don't want to like solder the expensive components to the board and then just have to throw them out. And these ordered from JLC PCB, these were, I think, like $65 for 5, which is...
With the components.
With the components on there. So this is our talking points here. So you can from JLC PCB you can get 5 PCBs for as low as $2 plus shipping, which is like reasonable. They offer mostly like FedEx and DHL shipping, so reasonable shipping prices. The PCBs themselves cost $2. I mean, they are incredibly cheap to make. They don't charge for the SMT assembly. They only charge for the components that you use. So they work with some components. So they're basically a subsidiary of a huge component distributor in China. So you just pay for the components themselves. But one thing that I think is really cool, and that I've just retweeted yesterday, basically the day after we said we were recording this podcast, is they also, you can not just use PCBs for electronics, you can also use them for other creative stuff. So for example, for faceplates, for like, electronics enclosures, you can just you can make a PCB. These are fairly structural. These are glass fiber reinforced boards. You can custom make a faceplate. You can have any sort of routing shape in it. You get the silkscreen print. You can do your, solder resist, which is another color. So you can do like 3-color print in any shape you want. And they've also got aluminum core PCBs now. So you can actually get something that's actually structural. And I've seen that before, for example, with quadcopters, where the entire frame is just a PCB. So that's something that interests you?
It's really interesting. How long does it take to get a PCB from like order to your home?
So from order to completion, I think is like 3 days. You can like express order and you can get them shipped out within 24 hours, which is crazy. But to get these to my home with like reasonably expensive shipping is a large part of what these cost. It's like 8 to 10 days.
Okay.
Which is reasonable. Like you do a project and you get them when you need them. You build everything else about the project, and when you actually need the PCB, you have it.
Really impressive. Yeah, I still on my bucket list need to wrap my head around.
If you need any help, let me know.
I will let you know.
And that is the sponsor spot for this video. Thank you to JLCPCB for sponsoring this video and for sponsoring this I live in YouTube video world. Thank you, JLCPCB, for sponsoring this episode. And now we're going to get dressed again into our regular clothes and continue with the episode.
Yes.
Sticking with the topic of recycling and waste reduction, you put one really interesting topic in there about the PETBot or the PETBot. That is recycling plastic bottles. And again, disclaimer, we already have systems for recycling plastic bottles. So is that something we actually need? I don't know, but it's something that uses a really cool principle. And you may have seen those TikTok or Instagram videos before where it's like, oh, we're cutting up this plastic bottle with like a little razor blade cutting tool and we're making string out of it. And the PETBot is basically doing that. It's first cutting it into a string, cutting a plastic bottle into a string, and then it is remolding, basically string pulling through a die that strip. And it's it's a chunky strip of plastic. It's pulling that into a filament, into an actual round piece of material that it can print with. Have you ever done anything like that?
I have. Well, the problem in Germany is that you have like the 25 cents deposit on all of the PET bottles, so you return them. So there isn't that much PET bottle waste that I would have to actually do that. And I think it's working really the best with those more or less 1 gallon jugs of Coke and things like that, those really smooth bottles. No, I have never done it, but yeah, the interesting process there is that they are taking that PET strip that they just cut from the bottle, and they feed it through a nozzle that is not heated all the way up, I think, to the melting temperature of the polyethylene triphthalate. Is it? Yeah, whatever. So as Tom said, they are just remolding and giving that strip a different shape that it comes out in the form of a filament. And I think you can buy the system at Precious Plastics on the Precious Plastics Bazaar for $400. And it is supposed to work quite okay and quite interesting. And the filament seems to be printable afterwards. PET is by itself a material that is kind of nasty to print. And I think this is also the reason why we basically don't have PET filament for 3D printing around, because it really warps a lot. Yeah. But I just found the process really interesting. One question that I had is that you're basically limited by the size of your bottle in the length of filament that you can extrude.
Right. Well, I mean, you can always weld some ends together, right? So that's something that could be solved. Though what I have thought previously about, or in the past about, when it comes to filament recycling, if you have something like a FilaBot, which by design isn't really the most tightly controlled system. Like, it doesn't have a constant feed rate necessarily, and it doesn't always make the best constant diameter filament. Could you take that filament and just pull it through a die? Could you like intentionally extrude for like 2 millimeters and pull it through a die that is 1.70 and have a bit of die swell with it and get perfect 1.75 millimeter filament with that? I'm giving you future videos You're welcome. Could you do that with a filament that is intentionally made for that process and get like spot on tolerances?
Maybe, but I think due to the maybe friction and just back pressure in the system, you will also be stretching the material after it leaves the nozzle. So I don't know how good it really comes out in terms of diameter. In the end, it's just an additional step, and the question is how can you set up your initial system that you get a more precise diameter out of it. Right. For example, with my old filler extruder, the filament diameter that I got out of the system was basically depending on having a really smooth and regular extrusion out of the nozzle, and then the weight of the filament hanging down before it got wound up by the filler winder.
Right.
And since this is not a controlled system, the filament diameter does vary due to like temperatures, extrusion rate, and things like that.
Yeah, if you have ground up plastic waste, basically, you don't have a perfectly constant
it's horrible to
particle
work
size.
with.
So yeah.
So the 3Devo composer that I now have, it has a closed loop system, so it also extrudes the material out that it comes out of a vertical nozzle, and then it's slightly cooled by a couple of fans, and then there is a puller wheel after that, and the filament or a thickness sensor, and depending on the thickness of the extruded material, it adjusts the speed it pulls at. Very similar to what is also used in industry, but in industry you usually have those long water baths.
Yeah.
Where I think you're able to get, where I'm quite sure that you're able to get your end diameter way more consistent than with the system that I have. But yeah, for that you need a whole industrial hall, and I have a desktop machine currently at my disposal.
Obviously, different starting situations. Yeah, with the big industrial ones, I guess there's so much mass, thermal mass, and also melt mass in your extruder that you are just naturally getting a constant diameter, and all you're correcting for is like getting the right diameter. So those little micro bumps where your extruder motor kind of catches on something, and all of a sudden you have less flow. You're not really worried about that with a industrial scale machine. So yeah. Check out the PETBot if you're interested. In the end, the question is if it's worth the $400 or $500 to extrude like small samples of material out of your PET bottles. It's an interesting idea. I think it's worth mentioning it. It probably won't save humanity right now, but who knows? Yeah, and like you said, for us in Germany and most of Europe, actually, it's just not viable to do because essentially you're paying 25 euro cents for a 50. How much? How heavy are those? Like 1.5 liter water bottles? 50 grams, maybe?
Less. I think it's. Yeah.
So in the end, that is quite the price you're paying for getting the raw material. And then another recycling process that I think we're just going to briefly touch on is we're now recycling, apparently, somebody's now recycling wind turbine blades into fiber reinforced PLA. So yeah, wind turbine blades, always a point of contention is like, hey, what do you do with them once their lifetime's over? Because they are a composite material that has either carbon or glass fibers in them. And, carbon fiber parts are naturally not that great to recycle because you can't melt them down. You can't, reshape them into something that is now the shape you want because it's a thermo set or a chemically set binder that encases those fibers. You can't get the fibers out. You can't get the binder into a material that is usable again, at least with current technology. So what's left to do is you grind it down and you downcycle it in the end. So big application is just concrete filler. You just dump it into concrete and that's the end of it. But with who is it? Engineers at the Canadian McGill University and Ryerson University. They're now grinding it down and putting it into PLA with a 10% fill, and supposedly it is helping the stiffness. Actually, a lot. 70% stiffness increase is what they're saying. And anything about any particular numbers about yield strength or tensile strength?
I think I have taken a look at the paper, but I can't remember.
Okay. They're saying it improves it at least.
Yeah. So what they tried is they were using the glass fiber reinforced. I think you said carbon fiber.
Either one, same thing in the end.
Same thing. They have been just grinding up the turbine blades, so you get basically a mixture of like chopped glass fibers and the remains of the resin, and put that into PLA. But they also pyrolyzed the blades, so they just burned them and took the ashes where supposedly a lot of the fibers still remained intact in there, and also put that into virgin PLA. And with both methods, they have seen quite a significant improve in stiffness, as you would always think if you put fibers in a material. It is an interesting application, though I don't know the amount of old turbine blades that we have compared to the small amount of maybe the carbon, or not carbon fiber, glass fiber PLA that we currently need is a bit disproportionate. But yeah, it is at least recycling or downside. Is it recycling? Is it downcycling?
It's downcycling in this case, because it's you're chopping down the fibers. You're creating a material that is less performant than the original one.
Yeah. And we briefly talked about that. Sorry, please continue.
Just a quick note before you go on. The amount of wind turbine blade material that is just there to be recycled or to be done something with is in the range of megatons per year. So possibly a bit more than what the total PLA consumption is even is right now.
Probably.
Okay.
The interesting thing, what I asked myself was, you downcycled the hard to recyclable glass fiber reinforced blades into glass fiber reinforced PLA, but those glass fibers, and even if you don't pyrolyze the material, if you just put the shredded stuff into PLA, they basically make your PLA not biodegradable and not recyclable anymore.
Yeah, because like we just talked about it in an earlier topic, like what you need to make sure your PLA is Schottenrein, it's not contaminated with other plastics, and a glass fiber stuff, glass fiber reinforced PLA would contaminate that for recycling. Though, again, recycling PLA and PLA prints isn't that big of a topic at this point yet. So, I mean, it's all going to the dump essentially, right?
Yeah, but I think the big it's partly greenwashing, but the big topic about why PLA is so great is that it's biodegradable. And with that filler in there, the PLA is still biodegradable, but what remains is the glass fibers and the epoxy resin. So, would make it maybe a bit of a better mechanical material, but everything else is maybe worse. I don't know. Well, the question is what the alternative for those blades would have been. Yeah. Well, chopping them down and putting them into concrete. That just shifts the problem like 50 or 100 years into the future.
Yeah. Well, I mean, wood-based turbine blades would be nice. I think there are actually companies working on that. Wood, I think, is a superiorly underrated material for a lot of these engineering applications, because it is essentially a natural fiber reinforced material, right?
Yeah, it just has problems with like being able to cope with moisture and other things that.
Well, you can seal it, right?
Yeah, but this
might
be something.
There is still a lot of work to do.
There is.
I guess one of the solutions would be just use less energy. Even if it's green energy, there is always a certain amount of emissions and waste, etc., attached to that energy. So just use less of it.
But since we all want to get like carbon neutral in the future, and we want to get rid of our charcoal. Is it charcoal? Charcoal.
Charcoal's is a nice stuff that's made from wood. But
yeah, our coal power plants. We somehow need to generate the energy, and if you take a look at our energy mix, there is of course solar, but I think wind power is also taking up a significant amount there. So.
It is a lot better than burning anything that's fossil. I mean, that's absolutely out of the question. But it's still like it's not zero.
All right. I guess that's enough recycling topics for today.
Do we have?
Do we still have one?
I just look up through the. No, we're done with recycling. We're actually done with recycling for today. Can I spin a segue to this next one? Nah, not really. Murph.
Well, Murph, yeah.
Murph. Well, Murph happened last weekend. You weren't there. I wasn't there. I saw a couple pictures. I was in Italy helping my dad move, so I didn't really I didn't catch much of what was happening there. And I guess neither one of us could even have attended if we wanted to. I made the choice I'm not gonna try it all, so I haven't looked into this, but apparently the US still has immigration restrictions for folks
the Schengen area
from the Schengen area from the EU essentially. I guess you could circumvent that by first traveling to another country and staying there for 2 weeks and then going to the US if you wanted to, like have a 2-week vacation somewhere. I don't know, in Ireland.
I heard of an ex-colleague of mine who just got retired and wanted to visit his, I think, daughter in the US, and they first flew to, I think, Panama or some other Middle America country, had a nice stay there at the beach, and then flew to the US, and that's possible. But I think currently you're still not able to get to the US.
Even for business. I mean, if it's like private vacation, I can understand that. But even business trips are completely out of the question.
Which is really crazy because that ban started, I think, 14 or 15 months ago.
Really?
Yeah, it was just before MRRF would have happened last year.
Okay.
And MRRF was in March 2020, I think.
April?
April,
I don't know
something like that.
When it was last year, but yeah.
And now it's July, so yeah, more than 12 months, which is kind of crazy if you think about that. That we are still at the point where we, are not yet able to go anywhere we would like. Something that, at least from Europe or like any other free country, you would have imagined in the past that something like that could happen.
Did you just call the US not a free country?
No,
they're nice there.
Since it is the 4th of July, of course, America is the freest of countries.
Oh yeah, absolutely. Yeah, well, we'll see how things go. Yeah, did we talk about the announcement of Earth versus MRRF? Did we talk about that last time? So
no, we did not.
Okay, so let's just touch on that briefly because it was that was an announcement just like 2 or 1 day from each other when MRRF posted, or when there was some news that MRRF's going to happen and we're going to tolerate mask use, and then the day after that, Earth was like, well, dudes, look, I don't think, or we don't think this is the correct time to have an international or possibly international event for 3D printing enthusiasts. Like, we're just gonna call it off for this year and we're gonna try again next year. We would have liked to put it on, but it's just not reasonable to do so. It is astounding how different the approaches there are between MRRF and Earth. And yeah, I do respect Earth for the decision to call it off for this year. Very much so.
As much as I would have liked to be there, and as much as I was sad when I have seen at least some of the coverage of MRRF, I think I would still not be comfortable just like being in a big crowd of people. My wife yesterday night was for ages again in a restaurant at night with a couple of friends of hers, and she said it was so strange because they were sitting inside because it was raining outside, but it felt in there like before COVID. Everything was totally crowded, no distance between tables and things like that. It's currently possible in Germany since there aren't that many cases and many are vaccinated, but it still feels really weird.
Yeah, I was in a restaurant in Italy. We were sitting outside, and there was some distance happening. Waiter was wearing a mask properly and stuff, but still, I was like, "Whoa, hold on! I've not been in a restaurant for probably 2 years. This is wow. This is odd." I guess that the US has. It's understandable that there's a feeling of, oh yeah, this entire thing's over because they have fairly high vaccination rates. But that's not the situation everywhere. And with Delta coming along and like possibly the vaccines that are not mRNA based not being that effective against that, it's I'd rather be cautious and saying, hey, this is, maybe we shouldn't treat this as it being completely over yet. But yeah, that was MRRF. What I actually wanted to talk about was the launch of the Kickstarter Sidebot. No, the Lulzbot Sidekick, which is finally a new printer from Lulzbot. Lulzbot have been, I don't know, they've not really had a truly new machine for a while. They've had the Taz, they've had the Lulzbot Mini. And those essentially stayed the same printer for 4 years. I don't know when the Taz came out, but I have an original Mini that still very much looks like what the Mini is today. It doesn't have the screen or anything, but it is what it is. And they now have the Sidekick series of printers, which is, I mean, I appreciate that it's finally new something. That it's finally something new. But there's been a bit of a communications mishap, I guess. So the Sidekick originally was announced as being expected to be as low as $750 for a 6.5-inch model, what they're calling the 289 because it's 1 point something liters of volume. So the 289 was expected to be as low as $750. And turns out it is actually $700 and it's nearly $800. Let me do the configure now. You can't actually configure the larger one, but it is $795 plus tax, obviously in the US as it's common. But for $795, you're not getting a 3D printer. For $795, you're getting a bed and a motion system. You do have to add on top of that a toolhead. Because they're saying, okay, for users with existing Lulzbot toolheads, apparently it's still compatible with the existing swapping system. Okay. So if you already have a Lulzbot and you just want the new motion platform, you can do that. But a toolhead costs another $195 on top of that for a 1.75 millimeter toolhead. So let me just add that. The Sidekick still comes with a glass and PI sticker system, which is what they've been doing for a while. But it's just not up to date anymore. So if you want a standard magnetic flex plate, that's another $30. If you want an LCD screen on your printer, which is the standard, graphic LCD, that's another $125. Filament sensor, let's add that for $20. No extended warranty for $600. Thank you very much. You come out to $1,165 for a printer that you would consider a printer. Like you get, a modern printer that's got a flex plate. Yeah, flex plate's $30, so whatever. But you have a screen, printer without a screen. When's the last time you saw a 3D printer without a screen? That wasn't like a $100, special application cheapo thing. And a toolhead, you're at $1,165, which isn't that bad, to be honest. Like I've seen people complain that it's so much more expensive than announced, and it is a lot more expensive than announced for an actual 3D printer. But it's all right. Though, again, you compare that against the Prusa, which is $1,000. It's larger and is possibly I've not used the Task Sidekick. I've not seen it even. Possibly a better printer overall, better ecosystem. I don't know. It's a tough sell. I mean, the Task 747 is not that much more expensive than the smaller one, so I think that's the one that people will be going for. But yeah, it seems to be a bit different, and it's been called a bait and switch, which maybe, yeah, if you don't include a toolhead with your 3D printer, that can be called out. It is certainly significantly less expensive than what the Lulzbot machines have been in the past, because I think the Mini was like $750 as well, roughly, and it's a 6x6.
The Mini 2 is $1,500.
$1,500, okay. Then I do have that. I misremembered that. Sorry. So the Mini 2 is $1,500. So it is a significantly less pricey system, even once you add those bits on.
Yeah.
And with Lulzbot obviously targeting a specific market that is in the US, specifically like schools and stuff, that need a product that is, as far as I know, just directly available in the US. That can make sense for those sort of customers. It's probably not something that you would buy as just a consumer, as somebody who's into 3D printing.
There are many alternatives, and I was just asking myself, what are the unique selling points of the Lulzbot besides made in the US?
Made in the US, available directly from a US company. That apparently is a requirement again for schools and stuff.
Yeah. How does that actually compare to the from Matter Hackers, the
Pulse?
Because the Pulse, because that's basically a Mark III.
Yeah, and the Matter Hackers machine is also going for that market, for being into going into education. Let me see. 8-bit board. I don't know what the Lulzbot runs. Possibly 8-bit. No screen. Let me get a standard screen on here. E3D Lite 6. Yeah. So the Pulse being a 20 centimeter, 8-inch machine. A Pulse is less expensive.
Yeah.
Like, no doubt.
I was already quite excited and interested to see that the Lulzbot machine, they charge $130 for just an old like a dot matrix LED screen, LCD screen. For the Pulse 3D printer, if you want to have the 32-bit board instead of the 8-bit board, it's $400.
Yeah.
Oh my goodness.
Why? I don't see that.
Well, probably they want to get rid of the old stock of their old bots that they're still having, but $400 for an upgrade to a 32-bit board, which probably won't even show in print quality or something else.
Yeah, no.
Because I don't know if
there are extra features in the 32-bit one, so I guess and also the 8-bit board should be more expensive to buy than the 32-bit one, because just the processor is a couple bucks cheaper. So,
well, try to buy an STM32 at the moment.
Well, true. So I guess they're factoring that in as well.
Yeah, maybe at the moment.
Having to buy having to pay scalper prices.
So it's probably a good point that you're mentioning that they're, well, not directly targeting makers just due to the price point. Its communication has been quite interesting. What I was also excited to see that I think all of the old machines were 3mm or 2.85mm filament.
The Lulzbot ones, yes. But I would assume with the swappable toolhead, you could just put a 1.75mm one on there. I think that's the point of having a swappable toolhead. Nobody's gonna notice that I've edited and screwed up the recording, right?
No, not at all. Maybe talking about swappable toolheads, how does the Lulzbot system work? Because you've been taking a look at the Wham Mutant.
Mutant, yes, exactly.
The Wham Mutant system. I just recently got my Mutant version 2 system, or at least kit. But I don't know how does the Lulzbot system work? Is it a similar system where you? Okay.
Let me see if we can find anything about them on the website here. So it appears, yeah. So it's not a click system, but it's one that you can take off with a couple of screws. I think it's still the same system as it's been on the Taz, which I have reviewed, and that's a fairly simple swapping system. Not slide in and it clicks into place, but a couple of screws from the back and the entire thing just comes off.
Okay. Yeah, that's kind of nice. The question in the end is always, how often do you do that? But what I find interesting, and this is also maybe one of the unique selling points of the new Sidekick, is that you have it configurable in a way that you can't really configure many other machines just right out of the box, because you can get it with different extruders, different filament diameters, different nozzle sizes, and things like that, which makes it maybe possible to more tailor it to the applications you intend to use it for.
True, though. I mean, let me just do the Sidekick 289 again. So there are a couple options for toolheads. I think that's where most of the customization is happening. You can get a carbide coated copper nozzle, nickel plated copper. You can get your standard brass info. Read more info. You can get your standard brass option. That's where most of the customization is happening. But the other options, like, hey, do I want glass or do I want a flex plate? Like, that's a no-brainer. Do I want a screen or do I want no screen? That's also no-brainer. Filament runout sensor, for $20 I'll just add this on. This is mostly like, adding the necessities to your machine. Mm-hmm. I think before we started, you compared this to like doing the starting from with like cars and stuff. It's like, do I just want the standard text-based screen in the center console, or do I want the color screen that does Android Auto and Apple CarPlay? Like, that's a no-brainer to get. Like, you're going to ruin your resale value for your car, and also your usability is going to be way, way worse. So I think all the options that you have, which is the magnetic plate, the LCD controller, and the filament sensor, either they are so cheap that they're no-brainers to get, or they're actually necessary to run the printer as people would typically use the printer. So customizability is mostly getting different nozzles.
Yeah. Though I gotta say, Prusa is also, for the Prusa Mini, selling the filament sensor as a $20 add-on. So it's not only like Lulzbot that who are doing that. Also, Prusa kind of tries to get the base price down by not including a filament runout sensor in their standard configuration.
And I did tease Prusa about that when they first announced it, and people are still giving me shit about, say, you're being so mean to Prusa. And I'm like, dude, like, come on, don't charge for it. Like, sure, it's marketing, obviously. It's a lower price, but if you really want the printer to be a printer and you don't just want like the cheapest possible Dacia Sandero or whatever, then you kind of have to add those options on, right?
Yeah.
So, that's the new printers from Lulzbot. I don't know. Maybe
have we heard anything from the printer bot?
I'm bad with names. So are you, apparently.
I'm horribly bad with names. From Brook Drum,
So from what I understand, it's not just Brook. It's a team of 3 folks now. Yeah. I think we've talked about it a while ago, but I don't remember the details.
I just thought about if there has been any news on that printer, which has the nice or interesting kinematics.
I have not seen anything about that.
Okay.
So.
Maybe we need to check on that for the next podcast.
Well, if there are any news, I mean,
it
doesn't look like there's anything to talk about right now.
Well, they had their Kickstarter, Was it on Kickstarter? I think it was on Kickstarter.
I forget. It's been a while.
Yeah, they had their campaign, so maybe there are some updates there. Anyways.
Yeah, let's try and tackle this last big topic here. I think so. We still have the Ender 7 in here, and well, it's another cheap printer, whatever.
It's not that cheap. It's $700. But yeah, let's talk about the Ender 7 next.
It's another cheap printer that's sold for more. Let's talk about this other one though. Chitubox Pro has launched. So a bit of a
that sounded weird.
Bit of a backstory to Chitu. So if you look at basically any low cost SLA or LCD resin printer, let's call them by the correct names. If you look at any low cost LCD resin printers, they are all pretty much the same. Like, it's no coincidence that they're all like using the same size, what is it, roughly 6-inch screen, that the interface looks similar, and they're all using Chitubox as a slicer because they are all the same. The core hardware is all supplied actually by Chitu, who make the mainboard, who make the slicer, who also supply the LCDs as far as I'm aware. They make the interface that runs on those boards. They make the firmware. They may even supply the LCD screen that's your touch screen that you interact with the printer on. So it's all a very simple system for manufacturers to make or to get into the markets of making an LCD printer. So all they buy the Chitu ecosystem, the platform basically. They add a Z-axis, they add a VAT, they add an LED, and an enclosure around that. And those aren't like hard problems to solve. All the problems that companies would actually need to put engineering power into have been solved by Chitu, and they just buy the complete package. Now, obviously, that gives Chitu a lot of power over the market and over the stuff that everyone uses, because essentially, it's a more or less, it's not that locked down, but it could be a very locked down ecosystem. So that's where we get to Chitubox Pro. So far, there's only been one version of Chitubox that you could use, or that you would use with your printers, and that is the regular Chitubox. But there's always been that little note of, hey, we're going to launch Chitubox Pro at some point. And, you know, when something's called Pro and it's a separate product, like obviously that's going to be a paid product. And from what I've seen, Stefan, you've looked into Uncle Jesse's video a bit. There's stuff around supports that only Chitubox Pro does right now, that the regular version does not do anymore. So what have you looked into what the actual differences are between the two versions?
No, I have not, but yeah, as it looks like that, it's a part of the support structure capabilities that change between the two different versions.
In the end, it kind of doesn't matter what the feature difference is right now. What kind of matters is how much they can still do and how much they can still put behind a paywall. Because theoretically, in the future, like, you don't know what base Chitubox is going to be able to do. Any feature that's in there right now could be put behind a paywall at some point, whether that's a one-time purchase of Chitubox Pro or whether that's a subscription service, as we've seen so often. Because Chitu have control. Like, they're using a proprietary format already, which right now still can be converted into with slices from Prusa Slicer or with Lychee Slicer, which is also a 2-tier product that has a $5 a month subscription if you want the Pro version. But right now, those two tools can still slice for Chitu printers, such as like the Mars D Anycubic machines, the Creality SLA printers, all of those. You can create custom files for that. But it's already a proprietary firmware. It's already a proprietary format. It's a lockdown firmware, more or less. And we don't know if with a future firmware update or with a future firmware version that ships with new printers released from here on out, that support is going to be taken away because the CTB format gains signing or gets encrypted or whatever other means that would not allow external G-code that was not generated in Chitubox to be used. So that's something that Chitu can very easily implement. So I guess the question is like, is this something that should worry you? I guess with the printers right now, as long as you don't intend on updating the firmware ever, and as long as you have a Chitu version that works for you, and as long as you can still use it, and that doesn't have like an expiry date set on it, which we don't know, I guess you buy the printer, you get to use it as it is, but that just that direction of development is kind of worrying.
It is worrying, but like from a commercial perspective, it's
absolutely
kind of logical, because in the end, you need to earn money some way. Of course, cash flow. Yeah, of course, Chitu, they have their cash flow when they sell their hardware, but if you want to have like continuous support, especially software and new updates, it's kind of logical to at some point start charging for more professional features. I think we are kind of not really used to that due to the FDM 3D printing world. Well, in the end, think 3, 4, 5 years back, if you wanted to get proper support structure, you bought Simplify 3D.
Yeah.
And I think something similar might also happen with resin printing at some point, that if you are not buying like recent software with more pro features, the workflow might not be as easy as it would be with that software.
So do you mean it's similar to Simplify 3, as in the company suddenly stops supporting their product and goes under, or which direction do you mean there? Oh, I'm just teasing. I think I know what you mean.
Yeah, no. Well, Simplify 3D, they do have kind of the problem that their software was a one-time purchase, so they had cash flow a couple of years back, but nowadays I think the only or the main amount of sales for Simplify 3D that they are having is just the professional 3D printing market.
Yeah.
That don't ship. That basically all of them ship with Simplify 3D. I don't exactly understand why, but that's I think
we've discussed that before. Yeah,
we've discussed it in the past. But the thing is, they have that cash flow problem, and I think at some point a software company, well, Chitubox, they also make the hardware, but if you, for example, I think take a look at Lychee Slicer, if they are a software company, at some point they need to have cash flow, so they need to charge for their software, and I think this is kind of logical, and I think it is also up to the point, okay, as long as Chitu says that their machines or that their hardware can also be fed or with a non-proprietary format, because that gives everyone the opportunity of choice. They can use a free slicer, which might be more work, might have less features and things like that, but might be totally okay for somebody who doesn't do that on a professional level. But if you want to go pro, if you want to go pro, you gotta spend some money, and I think this is okay up to some point.
Yeah, I see that, and the thing is with software, especially, it's always been that way, that there needs to be like some sort of cash flow happening, some sort of recurring purchase by the user. For example, like Photoshop, you could buy the software. Not anymore, obviously, but in the early days, you could buy the software once and you could use it as long as you wanted to. And then, if there was a new version that came out and you liked the features, you upgraded and you bought it again, or you bought an upgrade license or something. And that's where cash flow comes in. I do have kind of a problem with like subscription-based services such as Creative Cloud now with Adobe, because it means they can keep charging for the software continuously, even if there is zero development happening. Like at this point, Adobe can just charge all the people that are locked into Creative Cloud basically because they know it and their files are in that format. And they don't have to develop anything new. They can reduce the development pace by I don't know how much and get away with it essentially. Because as soon as people stop paying, they can't use the software anymore and they can't do their work anymore. So yeah, even though like a one-time purchase might be painful at the beginning, it's like, well, at least you're incentivizing the software maker to actually keep improving the software so that they keep getting more money or keep getting a continuous cash flow for that. So I don't know, what is the Chitubox Pro? I just know that it comes with the Mars 3 if you buy the printer outright. Is that a subscription or is that a one-time purchase if you want to get it separately? Buy now, let me see.
It is $170 for a 1-year subscription.
So it is a continuous subscription.
Yeah.
So I have to sign in to actually get to the pricing page. So it is a subscription. Well, $170.
$170.
Holy shit! That's an entire LCD printer.
Yeah.
That's crazy.
If you're using those machines in a professional environment, that's the standard. For like a maker, I think it's just way too much.
It's like
for.
Let me see. So the Mars 3, does that come with a perpetual license? Because it says it comes with Chitubox Pro, but is that just like a 1-year trial or something? Pro for free, no need to pay for it. Well, $12 months software license. Okay. It's in one of the photos here. Like and PM Eligu official on Facebook at Chitubox Pro license 12 months. So honestly,
how
that's
much is the printer?
So the Mars 3 is $300.
Okay.
Honestly, that is making the Prusa SL1S look cheap. You know, if you want all the features, you have this $170 a year subscription. Holy shit! Like honestly, that's sure. It's if you just want to try out the printer, it's fine. I mean, obviously, you can still use it with the regular Chitubox Basic, as they're calling it. But it just reinforces that argument that I made with Simplify 3D back then when they were kind of screwing up. Is like, take that money you're paying for your proprietary software and donate it to an open source alternative, and look at where it'd be in a year or two with the development effort. I'm
not that much. Sorry, continue.
I know stuff like FreeCAD isn't at that point yet, where they might be able to make full use of extra funding, but just the improvements that has made, I see potential there. If everyone who was paying for Fusion 360 was actually investing that into FreeCAD, wow, would we have one hell of a tool at our disposal for free. And once that company goes under, such as Simplify 3D, you don't lose all that investment. You now have something open source that others can build on top of, such as was the case with Slick3R and the transition to Prusa Slicer being kind of the mainline of that. Prusa took Slick3R Slicer as a baseline and built their own product on top of that, and it's still open source and everyone can still use it.
I'm not that much in the resin market. Are there any other open source SLAs, DLP slicers out there besides like Prusa Slicer?
I'm not aware of them, but there probably are.
Okay.
Because it's not. I mean, support generation is like the hardest part.
You could even do that in Mesh Mixer. If that would be the problem, but just slicing parts for
trivial
SLA or DLP or especially for DLP printing is way easier than for FDM, because you just send a picture to the printer instead of you have to calculate the whole print paths.
You basically have a full SL or a full LCD resin slicing path in every single FDM slicer. Because the first thing the FDM slicer does is it literally slices your parts into slices, and that is what you then send to the LCD resin printer. So I'm sure there are alternatives, but like, yeah. So also like, again, with the lock-in factor, Chitu now have a real cash incentive to lock people into using just Chitubox.
Yeah.
Into making it impossible to use something else. There is a real incentive there now.
Well, the question is if they would switch to a proprietary format, would this be an incentive for like 3D printer manufacturing companies?
What else
That's
is
the
out
problem
there?
because
It's It's the
kind of a monopoly.
Microsoft. The Microsoft, what is it? Embrace. There's more E's, but it ends with extinguish. They've basically pushed everyone out of the market by being so cheap and so universal and so accessible, so easy to use for the manufacturers. And now there's no real alternative. I'm sure there's going to be one if there's customer demand, but is there going to be customer demand? Is that going to be such a big issue that you can only use this one software if the software kind of does what you want to?
Yeah.
I don't know.
We'll see.
If it's cheap, people are going to buy it.
Yeah. And the thing is, if you get the pro version for a year, you not directly realize how maybe restrained you would be when you don't have that pro license anymore. And then after a year, paying $170 just to get your like old workflow going,
just to keep using your product as you were.
Well, if they still have a base version, okay, that's fine. But if you're just used to a workflow and used to features, it might be hard to switching to a really bare bones software.
Yeah.
On the other hand, in their defense, if that subscription money is used to further develop the slicer, add new features, add new just ease of life features, all right, I can in a way understand that. But it's just
too much. It's just too much. Sorry, like $170. Like, how is that justifiable when the whole machine costs not that much more?
Yeah,
it's that typical. Hey, is this more than Netflix? And I don't know how much Netflix is. I don't pay for Netflix, but is this like $5 a month? Sure, I guess that would be something that could be argued for. Though honestly, if you're paying for the full printer within 3 or 4 years, like $5 a month or $3.99 or something, that I think that would be appropriate and not worth of much discussion. But it's over $10 a month, and it's just too much.
Okay, so we'll see. I really hope to get back into resin printing since I built myself kind of a fume hood downstairs. So
nice.
Maybe I have the chance to try out different MSLA slicers just to see what the alternatives are and what how locked into that system you might become at some point.
Yeah. And I will probably be getting a Mars 3 at some point, so I can check that out with the included Chitubox license.
Yeah.
All right. And I guess that also answers the next question that we would have answered from Joe Jimenez. What would be... So we're in the Q&A section now. What would be your go-to printer for reproducing tolerance and accuracy? And I guess that question asks, hey, which filament printer would you choose? But I think we both had the same answer there. Don't use a filament printer. Go with LCD or SLA for reproducible tolerance and accuracy, because those are hard to beat.
Those are really hard to beat. We got maybe to talk about our sponsor again. So we got a presentation on their resins and what they are, for example, doing. They are scanning their 3D prints They are scanning 3D prints with different resins after the printing process to determine the amount of shrinking those materials have. And it's interesting to see that, like, from your CAD part to the final part, if you have the right resin and the right process and also the right printer, that you can get tolerances up to like 100th of a millimeter.
Yeah. Well,
easily.
If the resolution of your printer plays along, that's I guess the asker is there. But 1/100th, that's
resolution and accuracy, or reproducibility and accuracy are two different things.
Right. If it's just reproducibility, sure.
But if you're only in the market for FDM 3D printing, what would be the features or the things that you would look for if you would look for a printer that can print reproducible but also accurate? Maybe for once, print slow.
That's like the universal answer to everything, I guess. Print slow, yeah. I would have said get a printer that has a good software package attached to it, such as Cura and an Ultimaker, or Prusa Slicer and a Prusa Mark 3S or Prusa Mini or something like that. Because in the software is where you're going to get most of your reproducibility, reliability, print quality out of with today's printers. The hardware in today's printers is all pretty good and pretty capable. Like, you can get good prints out of most stuff. But if the software and especially the settings in that software is not up to spec or up to the test, then you're not going to make use of that hardware at all.
I think stiff motion system. I think even with the V-slot rails and V-rollers, you can get really good results if you want to get even like just one level better linear rails, because they even have less slop and should run even smoother. A print head that is not like flopping around in the breeze. But most printers nowadays, if you assemble them correctly and have everything properly tightened up and the belts tightened up, are able to print quite accurate.
To the level of what the process itself is capable of. Because at the end of the day, you're still squeezing out a semi-molten line of filament of plastic onto other, maybe not completely solid lines of filament yet. And that has some inherent shortcomings in what sort of shapes it can reproduce and how accurately and accuracy versus precision, how well it can reproduce those shapes. So
so maybe a direct extruder would also be more suitable than a Bowden system, because it has like less springiness in it.
Though if it's specifically about reproducible, like most printers are going to produce the same part in almost exactly the same fashion every time you hit print, if you print the same G-code. So reproducibility, I think, is just a given on most machines. Yeah.
Maybe one last thing, materials. Because if you want to have accurate parts, shrinking of polymers might like ruin quite a lot. Which means that if you're printing a part out of ABS, the accuracy is usually better if you don't sometimes scale the part, but the scaling is often not really linear and it gets more and more complicated. Just printing out of PLA might give you like the most accurate results, because it basically shrinks the least. If you want to get higher grade polymers that tend to shrink more, like nylon, ABS, PC, and things like that, the carbon fiber reinforced variants might also be interesting for you, because the carbon fibers, or all fibers that are included in that, will help you with reducing the amount of shrinking and also maybe help with accuracy. And if you have like a good quality filament in the first place, where the diameter doesn't vary that much, that will also help you in the end. And
especially one that you can order in like half a year again, and you get the same quality stuff. You get the same base material, you get the same tolerance. And some brands that you can get off of Amazon might just be rebrands off of whatever is just the cheapest supply at the time.
Yeah.
So do that. And I can hear you already getting tired. I'm getting tired as well. So I think that's going to be today's episode. Yeah, we're skipping that last topic for next one. Sorry, IOP Farmer. We're going to answer that next time. So I guess, Stefan, thank you for the time. Thank you everyone for watching and or listening. Can you imagine?
Thank you for your time and your flexibility.
Can you imagine just people watching the podcast and not listening to it, watching us on mute? I think that's got to be a weird experience.
No.
All right.
If you're good at lip reading, that might work, but I think that's kind of boring.
Automatically generated subtitles?
Ooh.
Would be
Let's
great.
read a podcast.
God. Yeah. All right.
Okay.
But that's it for today. Thanks, everyone. Thanks, Stefan. If you want to support Stefan or me, you can find Patreon links in the description below. Otherwise, just like, subscribe, comment, do the usual things, and we will see you all next time.
Thank you very much, and goodbye.
Bye.